sure I'm recording from the right channel. It is. All right, so I'm going to get started. This is the first time, well, not the first time, but over the past, I guess, 5 or 6 years, this is the first time we offer cisp310 in the fall, in the morning, during the day. Because this class has always been offered only in the spring, in the evening, and it's just impossible because I had 60 plus students in my spring class, and with a class like this, it's really hard to teach when we have 60 plus students in class. So this is good. We have a relatively small class here. So I'm going to get started with the syllabus and also how you can get all the resources for this class. I do not use D2L, I use Moodle. So as you can see, the URL of the class is at moodle.losrios.edu. So if you need to write down anything, this is the only thing you have to write down because you can get every other resource that you need for this class from the website here. Okay. So I'm going to write it down on the whiteboard just in case someone comes in later or just need to find some way to write it down or take a picture. Okay, good. So that's the resource. Once you get to Moodle, what you want to do is to log in. And depending on which browser you're using and what size of the screen you're dealing with. So let me just kind of log out first, and you can see this is the entry page. You go to the login box, and the username is your student ID. It's W followed by 7-digit. That's your student ID. And then the password is the same as the password for D2L, your apps.losrios.edu, all of your other stuff. So you guys are okay with that? Okay. So you can log in even if you're not in the class. If you're on the wait list, you can still log in. Okay, no problem. And I'll teach you guys, what to do if you're not in the class, you're on the wait list. You can still have access to the class material even though you're not officially on roster. I should be able to add anyone who wants to add to this class, assuming you have the prerequisites, because there are still room in this classroom here. Okay. All right, so let me switch to this one. I have two browsers, logging into Moodle because one I'm using as a teacher, the other one I'm using as a student, so they can see what you should be seeing as a student. There are several steps where that becomes important. So with this one, let me just kind of change the zoom back to the original, and I'm going to sign out, and I'm going to sign in again as a student. There we go. So as a student, I sign in, and under my courses, you can see that cisp310 is not one of the courses. Okay, so that's kind of reflecting what I should be looking at if I'm not enrolled in this class. If you are enrolled in this class, you should see cisp310 in this box here in my courses. Okay, but if it's not, you're adding to the class. That's okay. It's no big deal. You go to all courses here. Go to cisp310. Excuse me. Go to CISP. Scroll all the way down to cisp310 and click it. It will ask you for an enrollment key, and the enrollment key is that on the whiteboard. So you only need it if you're not enrolled in this class. Okay, if you're already enrolled, you won't need it. And for those of you with a mobile device, you can actually go to the Moodle website, with your mobile device. It is fairly mobile friendly, even with a smaller screen. I think Moodle does a fairly good job with utilizing a smaller screen. You should definitely you should be able to access all the resources with a mobile device. All right, so now that I sign in as a student, this is what you should be seeing. Okay, the first part here, this is the course website. The first part is accessible regardless of whether you have completed some of the activities or not. The other ones, on the other hand, they're all locked out, okay? Because you have to finish the syllabus acknowledgement activity before you gain access to the rest of the website. Okay? So what we'll do is we'll go through the syllabus first, and then I'll show you what to do with the syllabus acknowledgement activity. So as a student, you should be able to get to the syllabus. There are two versions of the syllabus. I'm just zooming in a little bit here. The first one is a PDF. You can print it out, put it into your binder if you want to. The second one is in XML format. You can just browse and take a look at the content with the second one, and that's the one that I'm going to use in class because it's easier to zoom in and out. All right. Are there any questions at this point? Any questions about how to get to Moodle, and if you're not enrolled in class, how to get into Moodle to get the resources? Okay, questions? So we'll start with stuff that you already know or you should know already. The first part, which is from here to here, that's stuff from the college catalog. So there's nothing really new here, except the content is a little bit different. I'm not going to really talk about B, C, D, binary coded decimal. The curriculum has changed a little bit to align with the CSU and the UC system, because they want to have this transfer degree. Is it in place right now? Do you guys know? I don't think it's in place. Yeah, there are some obstacles. Some CSU and some UCs are not cooperating. So it's not fully in place yet. I think you still have to go through assist to figure out what school you can transfer to. But anyway, we are in the process of realigning this class so that it becomes a transferable course to all UCs and all CSUs. So the content is going to be a little bit different, but the main concept will still be the same. So I'm going to go over the other part in just a little bit. The student learning outcome or student learning objectives, they are not listed in the catalog, but these are the things that you're supposed to be able to do once you get through this class and get a letter grade of C or better. I'm not going to get into this at this point because that's the whole objective of this class. This class has 3 units of lecture and 1 unit of lab, which means we have 54 lecture hours and 54 lab hours. The lab is going to be in room 158. 128, okay, which is just across from the hall on the other side. And so we'll go over there after the lecture so that you guys can do the lab activities over there. I think today we may or may not have time for actual lab activity. We may have some time for that. We'll see how far we can go with the lecture at this point. Any questions about this slide? Okay, let's move on to the next slide. Information about me. My name is Tak. Last name is Aoyang. You can just call me Tak. It's a lot easier than my last name, which is really just a vague, remote approximation of my actual last name in Cantonese. So it doesn't really matter. Tak is good, easy to pronounce, easy to yell to. My last name, it's really hard to pronounce it, especially when you need to do it loudly. My office is number 7 in Liberal Arts 133. That's also where the division office is. It's basically one aisle over on the other side. Does everybody know where to find room 133? This is 121, and this entire complex is 120 series. The next building over there is the 130 series. Office hours are Monday through Thursday from 8 to 9 o'clock, which is convenient for this class because it's right before this class. So if you need to meet with me, for whatever reason, you can just come to my office right before this class. Okay, so that's good. I'm usually in my office by 7 o'clock too, so if you really need to come meet with me early, that's also okay. Phone number is 484-8250, and I use my Gmail for class purposes, because this way it's easy for me to, kind of have one, set of one email address per semester. Okay, so it's easy for me to manage all my email this way. Okay. Section information. This is the Tuesday, Thursday section from 9 to 10:20 for the lecture, and then for the lab is 10:30 to 11:50. The final exam for this class is going to be on the 16th of December from 8 to 10 o'clock. So you might want to mark it on your calendar to make sure that you remember to come here for the final exam on that day. Okay, any questions? Moving on. Okay, this class does have a prerequisite. I'm getting into the class policies and rules at this point. This class has a prerequisite. You need to have taken cisp360 and get out of that class with a letter grade of C or better. I have checked the prerequisites, about a week ago. I think I sent out email to people who did not have, or with the online system, I could not check the prerequisite of those people. So if you received that email about 1 or 2 weeks ago, you will have to go through the prerequisite challenge process to make sure that you meet the requirements. How many people here did not take cisp360 somewhere within the Los Rios district? Okay, so you guys might have received that email, saying that you need to go through the prerequisite challenge.
I didn't receive your email.
Sorry?
I didn't receive your email.
You did not?
I did not.
Okay, so what you need to do is to go through the prerequisite challenge. Okay, you have to go to the division office and ask them for a prerequisite challenge form. Because I need everyone in this class to meet the requirement of having taken cisp360 or have equivalent qualifications.
Yep, I do.
Okay, so you can just get that form, and you can read through that form and attach support documentation.
Yep, got it.
You got it?
Yep.
All right. So you should be okay. All right. So you got it all approved already. So you just need to let me know after class. Then I'll just kind of mark you as as having met the requirements. So that's good.
Where is the room again?
It's room 133.
Okay, 133.
Yep, it's the Business and Computer Science Division office.
All right.
All right. So it's good to get it taken care of, early. Very good. So I do allow a 1 week window, which should be enough, to go through that process from the first class meeting, which is today, to get all the approved prerequisite challenge forms. Okay. Any other questions on this slide? Now, this is not really just because I like paperwork, or I like to push paperwork on other people. The prerequisite of this class is C++ programming, and there are many topics in that class that is important in this class. Okay, because what I'm doing is I'm assuming people know C++ programming already. I don't care much about the abstraction mechanisms like classes, instantiation, inheritance, and stuff like that. That doesn't, that's not important in this class. Conditional statements, loops, functions, procedures, pointers, structures, arrays, those are important concepts, and I'm assuming people know those concepts in C++ already when they come into this class. Okay. Next slide. Co-requisite doesn't apply because we do not have any co-requisites for this class. For attendance purposes, these reasons are excusable. Okay, they are excused. Sickness of the student himself or herself with a doctor's note or from our health service here. It has to be dated and signed, that's fine. Okay, if someone is sick and cannot make it to class. Any type of summon from the government is going to be okay too. So if you have a scheduled court appearance for whatever reason, okay, that's going to be excused. If you have jury duty, that's going to be excused. If you have military duty, that's going to be excused. So are there any questions about what is excused as for attendance purposes in this class? Okay. All right. The college actually has, or the district itself has a policy on excessive absence. A student may be dropped from any class when absences exceed 6% of the total hours of class time. Okay, I did not make up this rule. It is actually a Los Rios attendance policy that some people may know from your other classes, and some other professors do not care and they don't talk about it. 6% turns out to be 3.24 hours in our case, because you multiply 54 hours by 6%, and you get about 3.24 hours. We meet 80 minutes per session, which is 1.33 hours. So that means the third absence is going to cross that excessive boundary threshold. So that also means, what that means is, everyone in this class has up to 2 unexcused absences. You can be absent for no particular reason up to twice. Is that okay so far? Does everybody understand, how that number is calculated? Okay. And this is also from the college catalog. If a student is absent because of illness verified by the health center or personal physician, the absence must be excused and the student allowed to make up work missed. Okay, that's just copied from the college catalog. And here's the source, and I hope the link still works. Yep, there we go. So you have all kinds of regulations, from this link here. And you might, some people might actually want to go through all the regulations, the entire 2000 series, because they all apply to students. If you are sick, I understand that sometimes you are so sick that you cannot, operate a computer or the phone. You just kind of want to be out, rest and whatnot. But as soon as possible, let me know so that when I take roll, I know, okay, this student is sick. Do not drop that student from the class. Okay, so you want to do it as soon as possible, or have someone to call me or send me an email to let me know that you are sick on that day. Okay, so now the big question is, what if you missed the bus? Okay, well, if you miss a bus, it's going to be late, but not absent entirely. So what if you have another reason why that will make you miss this class entirely? Well, that's what that 6% is for. Is to afford up to 2 absences with basically no excuses. Okay. So are there any questions about the unexcused absences? No questions? Okay. Attendance for face-to-face classes. So in this class, I do take roll. I forgot to bring my roll sheet today, so I'm going to have to improvise and do something else for roll taking. But basically, I'll pass a roll sheet, for most of my classes, and use that to keep track of attendance. Does make it sound like elementary school, doesn't it? Except in elementary school, I'll give you, each one of you, a number, then I'll have you guys say 1, 2, 3, 4, and so on. And when the number is stuck, like, I'm, 14, 15, and 15 is missing, right? That's how my son's class, get attendance done, is at the beginning of each morning. They would just, each person will spell out the number, sequentially. So when it pauses, then the teacher knows, oh, okay, I see, Timmy is missing today because he's supposed to be 16, and 16 is missing. Classroom and lab behavior. Both this classroom and room 128, which is going to be our lab, are facilities provided only for the scheduled and intended coursework. So that means when you're in this classroom, it is for cisp310. When you're in 128, it is also for classwork of this class, cisp310. It doesn't mean that you cannot do your other homework, or silently study for another class. That's okay, but it is going to distract you from the content of this class. So I would prefer you guys to pay attention to the content of this class when you're in this classroom. What bugged me the most, would be, chatting, excessive chatting, during class time. If you have any type of related class-related questions, just raise your hand and let me know. I will try my best to answer your questions. For things that are not class-related, try to just wait until the class is over. Then you guys can talk about it, when you're out of the classroom. Okay. Any questions about, chatting? Nope. Okay. Cell phones, can be a problem. It's not a big issue. What I do with my cell phone is I install an app called Tasker. This is an Android, app. You can schedule your cell phone to go into silence mode, on certain times of the day, and then it will turn itself back on after that time. So you don't have to worry about not remembering to turn the ringer back on. It's really a good app because you can program it, not only based on time and date. You can also use the screen orientation to trigger certain operations. So if I put my phone, face down, that will also silence the phone because it can use the sensor to, trigger the silence mode. So it's a good app. I'm pretty sure there are free apps out there that can do the same thing. So I highly recommend installing one of those apps and configure it for your classes. Not just this one, but also for your other classes. I don't think pets is going to be a problem here unless someone has small animals hidden in a backpack. One time I had one student bring in a pretty big, gigantic, furry dog into the classroom. And it was not one of those, seeing dogs, that help other people or blind people. It was just a pet, okay? And it was pestering, other students. It was just, panting the entire time, really loudly, and it was licking, students around it, being very friendly. It's like, oh, you want to be my friend, and it was just distracting to the class, and that's why I put this item here. In this classroom, no eating or drinking in general, but since you don't really have a computer in front of you, unless you bring yours here, if you want to drink plain water during class time, that's okay with me, so that's perfectly fine. Okay. The reason is, if you spill, just plain water is just going to evaporate, it's not going to put a stain on the floor, it's not sticky, so it's okay, in this classroom. But in the lab, we still do not want to drink because you have a computer in front of you. And non-compliant students will be participants. Note that I use the term participant, which means that includes me. If you see me eating something in the classroom, you can just remind me and say, Tag, according to your policy, we are not supposed to eat in the classroom. And have you seen me eat in the classroom? Yeah, I try my best, not to break my own rules. But non-compliant people will be asked to leave the classroom or the lab, maybe just for 15 minutes or so, until they become compliant again. If anyone refuses to do that, I will have to call security. Okay, conduct code has mostly to do with cheating, academic integrity and honesty. So we'll just kind of go through this one a little bit here. In the next activity, there will be something related to this as well. Okay, this is really the essence of what I count as academic dishonesty. This one kind of lists all the different way of doing of cheating, but to me, this is more important. Academic dishonesty occurs when students participating in an activity to attempt to show possession of a level of competency, knowledge, or skill that they do not possess. Okay, that really is the bottom line. How it is done is not as important. It is what the intent of the activity is basically what defines what is cheating in this class. Academic dishonesty will may be reported to administration, starting with the Dean of BCS, the Business and Computer Science Division. And accumulation of these attempts, possibly from multiple classes, can lead to expulsion from the college. All participants involved in academic dishonesty will not receive points for the work submitted. So that means, if someone, gets the homework done on the first day, okay, when it's assigned, and let's say 2 or 3 people ask that person, hey, can you help me out? Can you show me your program? Because I'm kind of stuck. And they all turn in exactly the same homework assignment, the same code. Everybody is going to get a 0, including the person who's basically got it done in the first place. Okay. Activities including involving academic dishonesty is not going to count for attendance. The instructor may ask suspects to do additional work or explain submitted work in order to determine the legitimacy of submitted work. This one is here because in one semester, this is way in the past. Does anyone remember Pascal? The programming language, not the person. When I was teaching that class, that was a long time ago, I had one student who came into my office and asked me to explain a conditional statement in his own program. I think that kind of raises a flag and say, that's kind of suspicious. That person continued throughout the semester, acing all the homework assignment, but flunking all of the midterms and also the final exam. When he turned in the final project, which is kind of involved, because it's the final project, it did not compile. But when I went through the code without indentation, it's a Pascal program with no indentation. When I went through the code, it's almost perfectly done, except for no indentation, and I think there was a missing semicolon somewhere, and that's why it was not compiling. So I asked this student to, fix this program. It's not compiling. I cannot grade it. He had no clue of how to fix the program. So that's why there's an item here. But you might think, but Ted, you could have caught that guy, by comparing his code with the submission from all other students, right? I did that already. His code was so perfectly done that there was no match with any of his classmates. As it turned out, I think, at the end of the semester, he told me that he was getting help from someone from Sac State. So it was not from the same class. So there's no way I can cross-check it within the class. But that would certainly qualify as, not original work and not independent work. Which brings us to the next point. In this class, all work are expected to be completed independently, which means without the aid of anyone else during or prior to the activity, and also originally, which means it is not being copied or significantly derived from somebody else's work. Okay? So there's a big question here. So can we work on homework assignments together? The answer is yes, but in a certain way. Okay, there are certain ways you can do it without getting into any problems that is mentioned here. Okay, and sometimes I can retroactively re-examine any work that is already submitted and graded for any evidence of academic dishonesty. So I can do that retroactively. Grading scenario: what happens when submission of more than one student are identical or nearly identical? It depends a lot on the nature of the homework assignment. Like even for this class, the first few homework assignments, maybe there are only like 1 or 2 ways to get it done. Okay, then obviously many people will basically turn in the same code. I mean, that's just the nature of the homework assignment. But in the other homework assignments, they are complex enough where it is very unlikely to see identical code within the class size of this. Okay, so depending on the nature of the homework assignment, sometimes I can expect homework assignments or submissions to be identical, not nearly identical, but identical. But other times I can look at code that is similar and go like, that's not likely to happen. Okay. Same thing to the answers of questions in an exam. Okay, sometimes maybe the answer is just a number, and most students in the class will give me exactly the same answer. Okay, even the wrong answers can be exactly the same because most people will make exactly the same mistake, giving me the same wrong answer. That's fine. Okay, because that may be just the nature of that question. Other times it may not be possible or probable at all. So it all depends on the nature of the question, and the way I treat identical answers depends on the nature of the question. In your exams, there will be like several versions. I have had one student in one class giving me a perfect answer of the other version of the test. So for a particular question, the answer of this student was a perfect answer, but for the other version of the test. Now, how do I know which version of the test this student got? Well, it's the paper, right? It's on the paper itself. So the answer does not match the question on the paper, but it was perfectly correct. All right, moving on to number 5, important stuff. How do I map percentage to letter grade? That's a strange way to do it, but it seems to work for my classes, so I'm gonna continue to do it the same way. Anyone with 87.5% or more is gonna get an A in this class. Below that, if it is at least 62.5%, it is a B. Below that, if it is at least 37.5%, it's a C. So to pass this class with a letter grade of C or better is to get at least 37.5% of all possible points. Okay, and I'm pretty sure that's a little bit different from most of your other classes. When do they usually start the C in terms of percentage? 70%? Okay. Double that, yeah. Well, almost. Yeah. Well, but I don't ask easy questions. There's no padding in this class. A D is 12.5% to just less than 37.5%, and anyone with less than 12.5% gets an F. I think that's pretty fair. The distribution, you can actually look up my historical distribution of letter grades, A, B, C, D, F, somewhere online. It's actually public knowledge. Okay, it is not something that the college has to hold as secrets. Okay, as statistics. Okay, it is not a secret. Okay, it's not student privacy or anything like that. So you can actually look up the percentage of people getting A, B, C, D, F in my classes, and you will see the distribution of this class is very closely matching the distribution of the same equivalent class at UC Davis. So it just kind of follows a kind of more or less a bell curve. I usually have the majority people of my classes getting B's, with about half of those people getting, half of the people of getting B's getting A's, and then C, D's will be kind of tapering off. And sometimes I end up with more people getting F's than D's, which is kind of weird. But that's the nature of this class, sometimes. Your grade will depend on basically 4 components. The first component comes from all of your homework assignments. So all the homework assignments add up to 20% of your final grade. 40% of your final grade comes from the final exam itself. And you can see that if you ace the final exam, that's an automatic C already, because a C is 37.5%, and the final exam all by itself has more than 40, has exactly 40% of your final grade. Okay. The first midterm is 20%, not about, it's exactly 20%. The second exam is also 20%. Those will occur at 1/3 through the class and 2/3 through the class, the semester. Are there any questions about the proportions of each component of work that you have to turn in for assessment in this class? Questions?
I had a question.
Yep.
What does it mean mostly without any time limit, the second bullet point there?
Which part?
For homework, sorry.
For homework?
The second bullet point there.
That's a good question.
Are we going to have homework that does have a time limit?
Well, they have due dates.
Okay.
Yeah, they have due dates. Not quite sure why I wrote that.
Probably compared to the quiz, it has 2 hours.
Oh, right. That makes sense. So you have 7 days usually for your homework assignment, instead of just hours for your assessment, for the other assessments. All right, grading, FAQs. Okay, this one has nothing to do with cheating, but it has to do with certain people in the past have told me, I think I should get a better grade than what I'm getting because I'm spending a lot of time studying for this class. Well, I cannot assign grade based on effort. It has to be based on observable competence based on the tests and the homework assignments. I do not have multiple choice questions for this class, so we can kind of bypass this question. For all of the other questions in a test, in an exam, I use a rubric for each question. I use multiple rubrics for each question to assign the points. Okay, so that means if I have a question that asks you to fix a particular program, I would have a rubric of, is this problem fixed? And then under that, it will be like, yes, it is completely fixed. The student demonstrates the ability to locate a problem and fix it. Some students may be able to locate a problem, circle it, but don't know how to fix it. So they would get another grade or another percentage. And some students may miss that entirely. So that would get like 0 points in that case. But we're rubric based, and you can see exactly how many points you're getting for which criterion in the test. So I'm trying to make it as easy as it gets for me to grade it, and also for you to figure out why you're getting the grade that you're getting. There are no late submissions for this class, except when in the case of being sick. Okay, so that's an excused absence. All right, moving on to how do you help out a fellow student? Of all of my classes, cisp310 has seen the most of people working on homework assignments together. It probably has to do with the complexity of the homework assignment or the understanding of the material involved. So the question now is, how do we do it without triggering one of those problems that I have mentioned earlier? So I have a little sample dialogue here of two students. Student A, my program is not working. I'm stuck. Can I take a look at your code, your homework? Because I know you're done already. Okay. And student B, is the student who has the homework done already. And instead of giving student A the short answer of no, go away, student B is trying to help out and say, well, sure, let's see if I can help you. But I cannot show you my code. Okay, I cannot show you my answer. But I would be glad to answer some questions regarding the concepts involved in the homework assignment. So if it's a homework assignment involving, let's say, pointers, okay, so you can ask me about pointers, okay. I can explain what a pointer is, the operators, that work on pointers, pointer arithmetics and stuff like that. But I cannot, show you my code directly. Student A, knowing that student B will not show the code directly, is going for the second shortest route. Here's my program, fix it for me. Right? Can I show you my program so you can give me some pointers? Student B is not giving in. Okay? Student B is saying, I would still like to help you, but I would rather not take a look at your program. So don't show me your code. Can you describe the problem with your code without showing the code itself? Okay? Tell me what the symptoms are instead of giving me the actual source code and ask me to fix the source code. Okay? Student A does not like that answer. Okay, that's difficult. It's just not working. What else can I tell you? So student B is now probing a little bit deeper and ask, okay, so let's compare what you expect the program to do and what it actually does. Okay, because if the program is not working, it means the two behaviors, what you're expecting and what it is actually doing, are different. Can you tell me how they are different? Okay. And student A thinks about it a little bit and say, well, this loop is supposed to only go, it's supposed to have 4 iterations, but it's not getting out. It's becoming an infinite loop. Why is it becoming an infinite loop? Okay. Student B, thinks about it a little bit and say, well, what is the condition of the loop? Because that usually has a lot to do with whether a loop is infinite or not. It's not the only reason why you can get an infinite loop, but it's a very common reason to get an infinite loop. So the condition is x equals 4, and since all of you have met the prerequisite of CISP360, what happens when you have x equals 4 as the condition of a loop? What does it do? It makes x equal to 4, but it also has a side effect, because every expression in C gives you a return value. What is the return value of x equals 4? Assuming x is a real variable.
True.
True. So if you have a loop that has a condition of x equals 4, the condition is always true, which also means the loop is not going to exit, right? Okay, very good. So student B is saying, I see. So student B is still not giving student A a direct answer. Okay, so student B, instead of saying, oh, it needs to be a double equal symbol for comparison, student B is not doing that. It's saying, oh, what is the meaning of a single equal symbol in C++? Because student B does not want to give student A a direct answer. Student B wants student A to find the answer by himself or herself. Okay, student A answers and say, well, it's for comparing, right? I mean, it checks whether two numbers are the same or not. Student B says, no, I don't think so. And the student A, once again, wants the short answer, right? Tell me, what does it do then? Student B is going to give student A the most annoying answer possible in any of my classes. Tech just talked about it last week, okay? But I didn't take any notes. I missed that class because I was sick, okay? That's okay because Tech records all of his lectures. You can watch that again on YouTube. And at that point, you know, many of my past students will get kind of pissed and say, Tag, come on, just give me the answer. I don't have time to watch your YouTube again. You might think that's not the case. I just got that last semester. So, you know, student being a better person than I am, is still being very patient and say, encouraging and patient and say, it won't take long, plus it is beneficial to you if you just study your notes again or, you know, watch the video again. So student A is going to do it, even though he or she doesn't want to do it. Okay, and came back with an answer and say, oh, I see, a symbol equals symbol is an assignment operator, not an equality check. And student B confirms that. Okay, and basically asks the second question. Okay, you can see now that a single equal symbol is for assignment. What do you need for comparing for equality? Oh, I get it. It's double equal symbol. And student B confirms that and now asks, do you know how to fix the program now? Yep. Okay, just add one more equal symbol to the comparison and it's all done. Okay, so do you think this exchange is a little bit longer than just having student B to walk over and say, move the cursor key, press the equal symbol without saying a single word and say, it's fixed now? It takes a lot longer, right? Plus a lot more frustration on both students' part. But doing it this way, it doesn't trigger the original problem, right? Because the code is still being written by student A. It doesn't trigger the independence part either because, you know, student B only helps student A to understand the differences between the equality symbol and an assignment operator, but did not give the answer directly to the other student. Okay. So that's kind of an illustration of what I mean when I say it can still help out another student in class even though neither party should show the code, but you can still help out, you know, using this particular method. Study habit, I know, you know, you're in, you know, your fourth programming class or something like that already. You don't really need to talk about it, but I'll just kind of go over this really quickly anyway. Attendance of classes, you know, that's covered by the excessive, you know, absence policy already, so most of you will be attending classes regularly. Second, pay attention in class, bring something to take notes. Just because I record my lectures doesn't mean that there's nothing for you to record, okay? One thing you can do, okay, if you don't want to write down anything, the one thing that you want to write down kind of occasionally is a timestamp of when I start to talk about something important. Because if you want to review my notes or review my lecture using YouTube, that allows you to jump to a certain point instead of having to go from the beginning and just, you know, kind of fast forward a little bit, check it again. You know, if you just write down, okay, now it is 9:45 and Tech is starting to talk about how to implement, you know, passing parameters using the stack, that gives you a little bookmark So when you need to go back and revisit that part of the lecture, you don't have to watch the entire thing from the beginning. You can just kind of fast forward through the first 45 minutes. And it saves you a lot of time doing that. Okay. You also want to write down stuff that I do not talk about, because the screen recording will record my voice and also what I do on screen. It doesn't record what you are thinking when I'm talking. Okay? If you make a connection of two concepts that you previously did not connect, you have to write it down, because that's a very important moment for you, and I cannot talk about it, I cannot record it with my screen recording. Okay? So that is the kind of thing that you have to write down on your notes, when you make a discovery, a connection that you did not previously make, with the subject matter. Okay? What you do not want to frantically write down would be the sample code that I do in class, because I do type relatively quickly, and it's really difficult to write down everything that I do through the keyboard on screen, and it's going to be recorded for the most part. So if you don't have enough time, don't write everything down like that. Anything that can be recorded, do not write it down, but stuff that is not recorded, you should write down on your notes. Reading ahead of time is going to be helpful, okay, because at least that will give you an idea of what I'll be talking about. Priming your mind for the material that I'll be talking about is helpful, okay. Plus, it also helps to reestablish connection to concepts and other stuff that I have already talked about in the previous class. That is also important. And by the way, what is learning? I mean, you guys are here, taking a class, so I'm assuming that you're going to learn something. So what exactly is learning? How is it different from memorization?
Being able to take in knowledge and apply it to situations not previously mentioned.
Exactly. Okay. The application part is important. It's not just remembering something; it's making connection of those concepts to stuff that you already understand, and then be able to apply that and solve problems related to the material that I'm talking about. So in this class, all of the exams, the first exam, the second exam, and also the final exam, they are all open book, open notes. Okay, you can bring anything that is either handwritten or printed prior to the test to take the exam. In other words, I don't want you guys to spend your brain juice memorizing and just remembering the numbers, syntax, or anything like that. I want you to understand the material and be able to apply what you have learned in the class, and show me how you can reapply those knowledge. Okay. So that means it is also kind of important to study right after a lecture, just to kind of go over the material and make sure that you understand all of the stuff that I went through in class. Yep.
It sounded like you were specific as to it being printed or written down, so not computers, correct?
That is correct. No electronics, during the test.
Okay.
So if you do use electronics like a tablet or something like that to take notes, you will have to print it out prior to the test, because I only allow paper-based stuff during the test. The reason for that, is because not everybody can afford to have electronics. So I don't want to give people with electronics the advantage of being able to use electronics. Yep.
You said reading ahead would be useful.
Yeah.
I didn't see a required text for this class. Is there?
It's all on the website.
Okay.
In the order that is presented.
Okay. Great.
So if I'm going over a particular topic from a certain link, if you just read ahead a little bit of the next link, you'll be okay. Yep.
Will we ever physically need the book?
Only for tests, because you're allowed to bring in like printed copies of it. For the most part, people should bring in, they can bring in what I have, on the website. All the sample programs will be available in one form or another. But for the most part, once you study the material, it's yours. Okay. The most effective kind of thing that you can bring into a test would be your own notes that you specifically make for that test. Because by going through the process to make that note is one round of studying already. And for the most part, at least for myself, I have taken classes before where I am allowed to bring in like one sheet of paper. In the process of making that one sheet of paper, I will have to prioritize. I will have to study and prioritize what to put on that one sheet of paper. And going through that process is already studying for me, at least. Okay, it may not apply to everybody, but for me, that is already enough studying. And most of the time in a test like that, the one sheet of paper that I was allowed to bring in, I did not even have to refer to it. Just because in the process of making that one sheet, everything is up here already. I don't even need that sheet of paper. When you do have homework assignments, start on the homework assignments as soon as possible. Most of the time, I will give you 1 week to turn in your homework assignment. So that means, if you start early, you will have at least one class meeting to ask me questions about that homework assignment. Is that making any sense? Okay. So the way I do things is I will give you an assignment that will involve concepts that I'll be going over on that day. So there's extra incentive for people to pay attention because in that class there will be concepts that you need in order to do the homework assignment. But then the next class will be available for people who started early to ask questions about that homework assignment. And then the next class, it is due. Is that making any sense? Okay, so starting early definitely helps because you have more chances of asking questions. And even after an assignment is due, you turn it in, and even if you get 100% out of the homework assignment, I will always give you my solution. Okay, of all the homework assignments for this class, I always give you my solution, and it doesn't hurt to compare your solution to mine even when you're getting 100%, because you can look at different ways of doing the same thing, and you can even kind of evaluate and say, okay, but which way is better? Is one way better than the other way? Okay, if so, why is it better? Okay, it's not always the case that my solution is better. Sometimes it may be your solution that is better, but it's up to you to evaluate and find out which one is better and how is it better. That is always helpful. I use a lot of in-class examples in this class, especially to answer questions. I usually would use an example to say, okay, let me illustrate a concept with another sample program. So that means, when you study my notes, which is actually just kind of static stuff on the website, it does not include all the stuff that I do in class. But because the lectures are recorded, you always have access to stuff that I talk about in class, all the sample programs and whatnot. They're always at least captured by YouTube. So those will be useful as well. And if you want to print that out, for an exam, that's fine too. All right. So we are all done with the syllabus. What is remaining here is really just the schedule of all the stuff that we'll be talking about. And once again, this is based on the old curriculum. I'm teaching it according to a slightly newer, updated curriculum. So what I'm teaching may be slightly different from what you see here. All right. Are there any questions? Anything I can answer at this point? No? Okay. Then we'll go ahead and get started. So we are done with the syllabus, which also means this is a good time for us to deal with the syllabus acknowledgement. When you see this symbol in Moodle, it means it's a quiz. Okay, you have questions to answer. So when you click on this one, I logged in as a student at this point, so this is exactly what you should be seeing too. Is you will start the attempt, and it just has a bunch of questions related to the syllabus. So for the most part, the answer is quite obvious which one is the quote-unquote correct answer. So in this case, even if you don't read the question and just look at the answers, the possible choices, one is I do not have access to the syllabus, and the other one is I have access to or a copy of the syllabus. Okay, since you can log into Moodle and the syllabus is on Moodle, we do have access to the syllabus. Click next, and then was it a Mac or was it a Wally? Oh, you guys are not getting it. 'Cause I heard a computer booting up. And Wall-E made exactly the same sound when he activates. Wall-E, as in the movie, the Pixar movie, when he starts, it makes the same sound as a Macintosh. Being a Pixar, company which is related to, Steve Jobs. I can see some people are getting it, and some people are either think it's not funny or not getting it. Okay, so this one, same thing. I acknowledge the importance and the meaning of academic integrity / honesty, or I do not understand or acknowledge the importance. So the answer is A. Now this one, I just want to spend a little bit of extra time. It has a link to the academic integrity policy of Princeton University, and it is well written. Okay, it has its own explanation of how to help out a fellow student without getting into trouble with academic integrity. So I strongly recommend you guys to take a look at that particular policy, especially if you have plans to transfer to UC, CSU, Princeton University, or any of the Ivy League universities. Next. So I'm just going to go through this real fast at this point. It's not, it's not difficult. It's really just, you to kind of read through this and select that you understand and or acknowledge the topic. If you miss one, it's not the end of the world. You can always reattempt. You can attempt this as many times as you want. Oh, no, I did not choose to ignore. I understand that if I have not taken the required combination of prerequisite courses or taking the co-requisite courses, it is my responsibility to handle the paperwork to fulfill the requirement. Failing to fulfill the requirements, I will be dropped from this class. Okay, so I think I'm done here. Okay, so I'm done, and I have to click Submit All and Finish to finalize my answers. And it confirms, and I'm all done. So what I have done at this point is to acknowledge the syllabus and all the important topics of the syllabus. And the result of doing that is all of the other topics are now open. Okay, so this is what you need to do also, in order to get access to the other links and other resources for this class. Are there any questions about what I just did? Yep. Okay. All right, so this class is going to be using Linux as the main development platform. How many people have used Linux in one form, in one way or another already? Okay, so there's a pretty good percentage here. For those of you who have not used Linux before, it's okay, because I'm going to show you guys exactly how to use it in this class. There are a few questions as to, how are we going to do homework in this class? I want to give you the most flexibility as far as doing your homework is concerned. And using a virtual machine is the best way to do it. This is kind of outdated, so don't do anything yet, because on Thursday I will give you a distribution of a virtual machine that you can use that will be self-contained. Now, by means of self-contained, I means you don't have to install anything. You just download a zip file, unzip it into a folder, and that folder can be on a thumb drive, can be on an external hard drive, and you'll be all set. Okay? It will have a batch file. You double-click on the batch file, it will fire up the virtual machine, and you can do your homework in the virtual machine. Okay? So don't do anything. These links are active. Okay? They are still good, but I'm going to give you a version that is more portable than the ones that is already here. VMware is not exactly portable because you have to install VMware and you need administrative rights to install VMware. So what I will give you is something that you don't have to install at all. Okay, just unzip, double click on the batch file, and it starts up. Okay. Or you can do what I do here. I use an external hard drive to boot into Linux, so that's how I can get Linux up and running on these machines. Any questions at this point? No questions? Okay. Now, if you have Linux already installed on the laptop and you want to use that for your homework assignment, that's okay with me. The only issue that you might run into is my grading platform is a 32-bit system. So if your Linux distribution is a 64-bit distribution, you will have to do some extra work to make sure that you can write code in 32-bit and still make it run and debug in a 64-bit platform. It is possible, but you have to supply extra flags to the commands to get it done. Okay? The easiest solution to that problem is just to run a virtual machine. Even though you're using Linux already, just install a small 32-bit virtual machine and do all the work inside the 32-bit virtual machine. All right. So I'm going to skip these topics and defer the discussion of the platform to do your homework assignment until Thursday. Instead, I'm going to start with why do we need to study assembly language programming? Why are you in this class? Other than the fact that it is required. All right. So this is something that I wrote a long time ago. 2010. Let's see. I'm just trying to decide, the good order to do this. Let's look at this program first. I think that's probably a better way to do it. This program has a problem. Okay, so what I'll do is I'm going to show you a few things. Okay, the first thing is how do I get a program like this to assemble? I mean, not assemble, but to compile and run inside Linux. Okay, so I'm going to use a command line here and make a folder, change into the folder, and then paste into a program called badreturn.c. I have all that stuff already in my clipboard, so I can just paste, and then use Control-D to stop pasting into this program. And now I have this program basically quote-unquote typed in. And I use I like to use VI, but you guys can use Nano or some other editors. So here's my program. No, that's worse. I was turning on syntax highlighting. Okay, so since this class has a prerequisite of CISP360, yep, go ahead.
I thought you were going to ask what was wrong with it.
Oh, okay. Well, since you guys have all taken CISP360, you should understand the code of this program, right? The main program is fairly simple. All it wants to do is to call the subroutine G, which is defined here, do the printf, and then do the return. Okay. So the question is, how do I get this program to do something that is weird? Okay. It may not work the first time. I might need to give it a few tries. So I'm going to give it a run here. Okay. gcc-o badreturn.c. Segmentation fault. What? Even for a program like this, I mean, give me a segmentation fault? How's that possible? But that's not weird. Segmentation fault is bad, but not weird. Now, let me try to get this to do something that is actually weird. So I'm doing this kind of by random at this point, which is not really the best way to do it. If you don't want me to do it randomly, I can do the following. Okay, so we can do it -g first. A -g passed to GCC means you include debug information. So now I can use a debugger to help me. No. Oh, this is bad. I just overwrote the source file with the object file, with the executable file. So now their badreturn.c is gone. No, it's still here. Okay. Okay, there we go. So I'm gonna go into GDB. You don't have to write down anything here because we'll go through these very slowly during the class. I just want to give you a taste of a program that is acting weird and is difficult to explain using only what you know about C and C++. Okay. So I'm going to print subroutine here. Let's put 07. 07 is what I need. Okay. That's the executable. Okay, it still gives me a segmentation fault, but before it gives me a segmentation fault, it prints this is weird. Okay, so remember the symptom of the program first, okay? It prints this is weird, and then it has a segmentation fault and just bombs out. Okay, so when you look at the source code of this program, don't you think this is really weird? Because subroutine F was never called. It was written, it was never called. Main called G, G returns. Main is supposed to print this is not weird and exit the program. So how did it get to subroutine F in this case? It was never called.
You assigned a value to an array that is out of bounds.
That is out of bound. So
It overrode what was seemingly a random memory address, but it's not random.
it is not random at all. That's why, that's why I had to go to GDB, figure out something, come back, then I knew exactly how to edit the program so that it would print, this is weird, okay? That is the reason why I think people should take this class. Not because you think, in your career of being a developer or software engineer, you'll be writing a lot of code in assembly language. Most people would not, okay? Most people would write a few programs in assembly language programming class and never touch assembly language ever again, okay? But it doesn't mean that people should not learn assembly language programming, because is there any assembly code in this program? No, they're all pretty much plain vanilla C code. Are there any pointers in this code? Nope, no pointers, right? Nothing really tricky looking in this program, and yet it gives you the weird result of getting into a subroutine that was never called. Okay? Now, at the end of this semester, I'm hoping that everybody will be able to look back at this program and know exactly how it works. Okay? Why it prints this is weird instead of doing something else. Okay? In other words, this class, I am structuring this class so that it gives you the skill set to debug C++ programs more effectively than only with CISP360 and CISP400. So I'm making this class more or less a pragmatic class instead of just saying, oh, okay, this is the kind of stuff that you need to know because all the UCs and all the CSUs expect you to know this stuff by the time you transfer. Okay? Are there any questions about the objective of this class? From the perspective of, well, why do I need to know about assembly language programming? How would you debug a program like this? I mean, this one is obvious, right? It is obvious because I came to this part here and intentionally kind of modify this number until it prints, this is weird. But in real life, it is going to be completely concealed, right? Because you have a 5,000 line program without, tricky code like that. And then one day your program is going to behave kind of like this, okay? There's a subroutine that is defined but never called along the tree that you're calling. But at some point of time, it somehow gets into that particular subroutine with no particular reason at all. But how do you debug a program like that? Well, hopefully with the knowledge that you gain in this class, you will start to say, I know something on the stack is modified. Okay, it's probably the return address of something. So that means I'm accessing an array or a pointer out of bound, modifying something on the stack. So knowing that gives you an ability to say, okay, this subroutine does not have any pointer arithmetics at all, cannot be this one. At least you have some way to kind of proceed and find out, okay, which subroutine can even be a suspect of a problem of this type of magnitude. Okay, so this is, I think it's a really kind of cool program because it just demonstrates something that you don't see every day. But if you use pointers in C++, at some point your program will behave, kind of strangely that cannot be explained only using what you know about C++ and C programming. Right? So getting back to my notes here, and I can back out to this note here. I think I started a new window for that. Yep. Okay. So we're going to start with kind of more generic type of information and what you know already. Okay, this is the kind of stuff that you should know already from your previous classes. There are many high-level programming languages: C, C++, Java, PHP, and so on. They're all considered high-level programming languages because, well, for the most part, you can understand the code without having to retrain yourself. Okay. So they closely, quote-unquote, resemble logic concepts that people use, especially if you use one of these programming languages already. Learning the next one, it's going to be pretty easy. A program source file of most high-level programming languages is just a text file. Okay? In other words, the program that I just typed and all the homework that you have done for cisp310, each file is nothing more than a regular text file. Okay? It's made out of ASCII characters, and it has meanings to you, but it has absolutely no meaning to the CPU. In other words, if I go back to here, I can do a hex dump of bad return.c, the source program, the source file, and these are the bytes in that particular file. 23 in hexadecimal is the first byte, 69 in hexadecimal is the second byte, and so on. These numbers they have no meanings to you until I print it out as the actual ASCII characters. It means pound, include, less than, and then standard io.h, and so on and so forth. That's meaningful to you because you know how to do C++ programming already, but has absolutely no meaning to the Intel x86 processor. Okay, it looks at these numbers and go like, yeah, well, what do you want me to do with it? I don't know what to do with these numbers. Okay, so that's why you need a compiler. So the next slide talks about from the processor's perspective, what does it understand? Okay, what can a processor do, or what kind of instruction does it understand? When does this class end? I think it's about time, right? Is it 20 or 20, right? Yeah. Okay, so we have a few more minutes here. Okay, so what I want to do is to look at the I386 instruction set. Okay. It's not important. The actual instruction set is not important. I do want to show you. Let's see. Let's pick a simple instruction here. Okay, well that's a fairly simple instruction. It is add, and you can see that the opcode is specified. Let me just pick one that is relatively easy to pick up. Maybe another representation. Instruction set. There we go. Okay. So the add instruction has, it doesn't give me the binary code. Oh, okay. I guess it's the same thing. Okay, the opcode in this case, adding immediate to a register. Okay, let me talk a little bit here. Okay, the opcode is 04 in hexadecimal, which means in binary it's going to be 0000 0100. That's the first byte. The second byte is the immediate content, or the immediate value. So it's going to be whatever 8-bit number you want to specify is going to be the second byte. Okay. So if you want AL as a register to get 0 as a number, is going to take up 2 bytes as an opcode. The first byte is going to be 00000100. The second byte is going to be 00000000. So combined, these 2 bytes is meaningful to the x86 processor. It means change register AL to 0. Okay? And how many opcode do you think we have with the x86 processor? A lot. Okay? Just for the add instruction, we have this many. These are all for the add instruction. It's just the different ways of using the add instruction. Okay? Do you want to write your program using these hexadecimal numbers? Look up a big, huge table and say, I want to add this register to that register, but how do I specify that instruction? Let's look it up here, and it depends on which register you're dealing with. So if you want to add, no, it doesn't have a register to register. Here maybe it does. Okay, so if you move down here, it has a register to a register. So you have to look up the table, figure out which register you're dealing with, and then figure out the actual binary bit pattern for that instruction. And that's what the processor understands. Do you see a big gap between the program that I just wrote in C++ as opposed to the instruction set that your processor actually natively understands? Okay? So what's going on in between? What does GCC does? What does GCC do when I run GCC? It translates, exactly. Okay, it's translating C++ code to the opcode that your processor understands. Okay? And here comes another question. When the first computer was invented, or when the first batch of computers were invented, how do people write programs on those computers?
Patch cables.
Punch cards?
Punch cards. Well, punch cards are nice to have, when you have the money to, actually purchase a punch card machine, a punch card reader machine. So what if you're getting an Altair, computer, the first personal computer? Well, let's take a look. Now, I know it may not look like this is related to this class, but it does. Okay, so Altair computer. And we'll just take a look at one of these pictures. I just have to pick one that is representative. Okay, so here's the Altair computer. We'll zoom in a little bit here. That's your entire user interface. There are no USB ports in the back for you to plug in the keyboard and an HDMI port to plug in the monitor. Okay, this is it. This is the entire front panel that you use to interact with the computer. We can see some LEDs, okay, so they can light up. It's either on or off. But how do you get something input into the computer? What do you see on this picture that is something that you can do as an input device?
Switches.
Yep, toggle switches. You flip it up for 1, you flip it down for 0. Okay. A group of these switches control the address, and another group controls the content. So if you want the computer memory location 0000 to contain a certain value, you flip the first group of switches to specify the address, the second group of switches for the content, and there's one toggle at one place or another to say latch. Okay, remember this now. Okay, that programs one location in the memory of this computer. What do you do to program the next one? There's no next button. You have to control the address again, specify the content, and say, remember, this is how you program computers like these. Okay, one location at a time. But what are you programming into the memory of this computer? The opcode of the instructions. Okay, so you have to look up that table and find out if I want to specify the instruction to add one number to another number, what is the actual binary representation of that instruction? You have to look it up. Okay, that's how people program computers at the very beginning, because this is before assemblers even existed. There's no assembler to help you in this case. Right. So the next slide talks about assembly language. So assembly language is not really the lowest possible level, because what I just talked about, using switches, zeros and ones to specify instructions, that is the lowest level. Assembly language is actually considerably easier to deal with compared to zeros and ones. So when we have assembly language, it is already much better, because now we start to have what we call mnemonics. A mnemonic is basically an abbreviated word, and sometimes really obscure, that specifies an instruction. Like MOV stands for move, JMP stands for jump, and so on. ADD stands for add, so it's a lot easier because you don't have to remember the binary code of instructions anymore. It can also allow the use of symbolic labels for branching and allocating memory for variables. So you don't have to keep track of which location is in use for which variable in your mind. It is automatically tracked by the tool itself. So it is already a lot easier compared to using binary code or machine code to write your program. An assembly language differs from an XLPL, high-level programming language, in that a programmer gets to specify the exact CPU operation directly. In other words, you still have pretty much 100% control over the instructions for your particular program. It's just that you don't have to use zeros and ones to specify those instructions. And you can use more or less symbolic names and other things, labels, to help you write the program. So it kind of gives you the flexibility or the convenience of not having to know the binary code, but at the same time it gives you direct control of what instruction is going to be in your program. When you write a program in C++ and it is compiled, you don't really get to choose which instruction is used. The compiler will get to choose what instruction it's going to use. And by the way, do you think the compiler is better or a human programmer is better when it comes to translating a high-level concept like a loop or a conditional statement into assembly language code?
Computer.
Yeah, it depends on when this question was asked. Okay, if this question was asked 20 years ago, it's a person. But since the question is asked today, it's mostly the computer. The compiler can optimize code better than most people. Okay. All right. So, are there any questions about this slide about assembly language and how it relates to high-level programming languages? No question. Okay. Moving on. Oh, we are running out of time. Okay. Yep, it is. All right, so let's go ahead and take a break. The lab is going to start in room 128. There's nothing to do today, so if you have other things to do, we don't have to go there. But I will be there in room 128 if you have any questions about the stuff.
Taking roll.
I forgot to bring my roll sheet. So I'll take roll on Thursday.
Okay.
Yeah.